Hello everyone, so today we're going to look into some characteristics of quadratic functions. Really looking at some specific points that are important as we look at quadratics and some of the graphing. Tomorrow we'll really get into the graphing of quadratics. Okay, so characteristics of quadratic functions. The zero function is, let's just say, an x value that makes the function equal to 0. This is the same as an x-intercept. Now, we've talked a lot about y-intercepts, but not so much about x-intercepts of the function. This is probably the most important point on a quadratic function. Yes, the turning point of vertex is important. Yes, the y-interceptor is important. But almost always, you're going to work on finding the x-intercepts or zeros of the function. A quadratic function may have none, 1, or 2 zeros. Remember, an x-intercept is the value of x when y equals 0. So you can always plug in 0 for y and solve. So finding zeros from a graph. Now, zeros can also be called roots, solutions, or x-intercepts. So you're going to sometimes hear any of those. So you can hear roots, solutions, zeros, x-intercepts. They're going to all be interchangeable. Now it's where, and the dogs are going crazy right now, it's where the graph crosses the x-axis. So where graph crosses x-axis. So this is the x-axis right here. And the graph crosses this x-axis right here and right here. This point right here is -1, 0. And this point right here is 2, 0. Meaning that the zeros are -1 and 2. So this has 2 zeros. And sometimes you're going to see zeros spelled like this. Sometimes it's going to be ES. It just depends. Now this one right here crosses the x-axis right here, and this point is 1, 0. This has 1, 0 at 1. And you can sometimes put the point, or you can just put the number. It just depends. And lastly, this line right here never crosses the x-axis. This has no zeros, and sometimes you'll just see none. It never crosses the y-axis. What other important point is this point right here besides a 0? It is the vertex. So just a reminder that that is the turning point, so it's also the vertex. So when you have 1, 0, it's not only the 0, it's the vertex. That's the only time that happens. Every parabola has an axis of symmetry. The axis of symmetry is the symmetrical the turning point, also known as the min or max of the graph, of the parabola. So let's identify the zeros and the axis of symmetry. So first of all, the zeros are at -1 and 3, because this is -1, 0. This is 3, 0. So -1 and 3. Sometimes we'll just put commas between the zeros, and that works too. The vertex is right here, and that's at 1, -4. And the vertex is always written as a point, so you have to write the point. And then the axis of symmetry. Now that's the imaginary line that crosses through the vertex. And this line, since it's a vertical line, is at x equals, what does x equal here? Well, it equals 1. All along this point, x is 1. So x equals 1. And we write that as the axis of symmetry. It's x equals 1. X equals 1. All right. For the next one, first of all, is this concave up or down? Said concave up. So is the A positive or negative? The A is positive. This one, is it concave up or down? It's concave down, so is the A positive or negative? It's negative. So here, Our zeros are here and here. This is -1, 0, and this one is -3, 0. So our zeros are -1, -3, as you can see. Normally they're written like that with a comma, so we'll write them like that. The vertex, that turning point, is right here, and that's at -2, 2. And lastly, that axis of symmetry, going through the vertex and cutting that graph in half. Like if I were to fold this in half this way, if I were to fold it in half like this, right on that line, each side would be symmetrical. This line is symmetrical at x equals -2, because x is -2 right here. Because this point is -2, 0, this point is -2, 1, this is -2, 2. Basically, whatever your x is of your vertex, that's what x is equal to. So in this case, it's -2. And lastly, our zeros here are at 0 and at 4, 4, 0. So this is 0, 0. This is 4, 0. So our zeros are 0, 4. And then our vertex is right here. Is this graph concave up or down? It's down, so this has a maximum vertex or turning point, and the A is going to be negative, and this point is at 2, 4. And like I just said, our axis of symmetry should be at 2, but let's double check this. If we draw an imaginary line, and imaginary lines are always dotted, think of our exponential asymptotes. This is going to be at x equals 2. Okay. Now, if you do not have a graph, or if the axis of symmetry is hard to see, you can use a formula to find it. And you can also use many different ways to find the zeros. We're going to talk about that. That's going to take us a couple of days. We'll talk about that next week. But specifically for the vertex, there is a formula. And that formula is x equals -b over 2a to find, let's say, the axis of symmetry first. So the axis of symmetry, -b over 2a. Now, this is all based on y equals ax squared plus bx plus c. Remember, that's the standard form of a quadratic. So now that we come back to that, what you were working with yesterday when you did a parentheses x minus h parentheses squared plus k, that's called the vertex form. And you can find the vertex from this, but we're working with standard form. So first, you always have to make sure your equation is set equal to y. So let's put make sure equation is set equal to y. If it's not, you do this. And it has to be in descending order. So like this is x squared, the next one is just x, and then if you have a constant or a number after that, that's what goes next. So looking at this right now, we're going to identify a, b, and c. So our a is the number in front of x squared right here. Our a, there's no number, but there's a negative sign. If there's no number there, we assume there's a 1 there. So this is -1. Our number in front of, or our number which is b, which is in front of x, is -2. And there is no c, so we just say that's 0. There's no number after -2x. So now we're going to plug in -b over 2a. Well, b is already negative, so a negative makes a positive. It means also the opposite of b. So -2 means +2 over 2 times our a, -1. 2 times -1 is -2. 2 divided by -2 is -1. So x equals -1. All right, our next one are a, b, and c. And if you look at higher math, almost always you will see people identify a, b, and c in this like scenario. So a is what's in front of x squared, that's 4. B is in front of x, that's a +10. And c is what comes at the end, the number by itself, which is 6. Now, currently, we're not using c for anything, but we are going to be using all of these numbers later on, and that's why I want us to be able to identify all of them. So -b, this is a positive, so it becomes negative, -10 over 2 times a. This becomes -10 over 8. And if we reduce that, we get -5 over 4. So negative 5/4. You can also use negative 1.25. I'm okay with either one. And our last one. Try and do this one yourself before I do it. So pause the video. A, B, and C. We get 2, 4, 5. So we get negative 4 over 2 times 2. 2 times 2 is 4, so negative 4 over 4. And x is going to be equal to negative 1. So that's how you find your axis of symmetry. X equals negative b over 2a. And I'm going to tell you for Math 1 and Math 2, this has to be memorized. You have to be able to find this by yourself. Now, to find the vertex from that, since the axis of symmetry splits the parabola in 2 equal halves, the axis of symmetry is also the x-coordinate of the vertex. Just like here, x-coordinate, axis of symmetry, x-coordinate, axis of symmetry, x-coordinate, axis of symmetry. So, to find the vertex from the axis of symmetry, you plug that x value of the axis of symmetry back into the function. So we're going to take this and plug it back in to solve for the corresponding y value. This is your vertex. So using the 3 examples from above, we're using the same ones. Find the vertex from the axis of symmetry. So my x up here was negative 1. Now what I'm going to do is I'm going to plug negative 1 into all these x values. Remember, when I plug in, I am plugging in parentheses. So I get y equals negative, parentheses, negative 1 squared minus 2, parentheses, negative 1. So what I did was everywhere there was an x, I plugged in negative 1 because that's what x is equal to. And now this is going to be really helpful for you. You can either do this in your head, and if you can, please do. Or you can just plug this straight into Desmos. So negative, and plug it in exactly as it's written. And you get 1. When you solve this, you get 1, and you should see that right here. It's not highlighting for me, but you can see that right here. So here I get y equals 1. So my vertex is negative 1, my x value, and then my y value, 1. All right, for the next one, we're going to do the same thing. This time it's negative 5/4. I said you can also use negative 1.25. So that's what we're going to use as we type this in because it'll be a little bit easier typing it into Desmos using this. So we get y equals 4 times negative 1.25 squared. Again, I'm just plugging negative 1.25 everywhere I see x. And as I plug it in, I'm plugging it in parentheses. Plus 10 times negative 1.25 in parentheses. Plus 6. So I'm going to plug this into Desmos just like it's written. And I can put my y equals, but it's okay if I don't. Negative 1.25 squared plus 10, negative 1.25 plus 6. And I get negative 0.25. If you want to change that into a decimal, it's equal to negative 1/4. And you can change that as you wish. But I'm just going to use the decimals as I write this. So my vertex is my x, negative 1.25, and my y, negative 0.25. You could put 0.25 or just 0.25. Either one's right. Okay. And last but certainly not least, my x here was negative 1. Up here, we do y equals 2, parentheses, negative 1 squared, plus 4, parentheses, negative 1, plus 5. Again, we can put this into Desmos. And we get, oops, plus 5. And we get 3. So here y equals 3, which means my vertex is at negative 1, 3. We're going to double check this one in Desmos. Just because it's always good to double check, especially when you're on a calculator active section, you can always double check everything in Desmos. So all I'm doing is writing this function in so I can see the graph. And if I go to the vertex, which is one of the points, it says there's a vertex at negative 1, 3. So it's perfect. Okay. Hello, Doe. The other thing I wanted to show you while we're up here is the y-intercept. If you notice, the y-intercept's 5. And if you see your equation, the y-intercept on the equation, or sorry, 5 is your c in the equation. C is always going to be your y-intercept. That's going to help you out a little bit. So let's come back to here. Hello, Doe. We're going to practice this. And before we start, I want you to... No, ma'am. We're done. Before we start this, I want us to write up here, C equals y-intercept. Because that's going to really help you as you graph all of these. All right, we are going to do 6 of these, so don't stress about getting through them all. But we are going to do some of the, actually we might only do 5 of these. We are going to do some of these. All right, so let's start at the top. There is no number in front of x, so we assume 1 there. There's no x value at all by itself, so we put a 0. And there's no number by itself at all, so we put a 0. Again, we're working with the equation y equals ax squared plus bx plus c. There's no x, so there's no b. There's no number by itself, so there's no c. So we put zeros. There is an x squared term here, so that's why we know there's a 1 in front of there. Now, what I can do is I can plug numbers in and solve. So if I plug a 1 in, or sorry, negative 1 in, negative 1 squared is 1. Negative 1 times negative 1 is 1. Plug a 0 in. 0 squared is 0. Plug a 1 in. 1 times 1 is 1. Plug 2 in. 2 times 2, or 2 squared, is 4. Plug a 3 in. 3 squared, or 3 times 3, is 9. Now, the axis is symmetry. Remember, it's negative b over 2a. Well, my b is 0, so my axis of symmetry would be negative 0 over 2 times 1. Negative 0 is just 0 divided by 2. 0 divided by 2 is 0. So my axis of symmetry is 0. My vertex, then, if I plug a 0 in here, is 0, 0. Does this have a minimum or a maximum? Well, my A is positive, so it has a minimum because it's concave up. The y-intercept, remember I told you your C is your y-intercept, so the y-intercept is 0. And the zeros, where do we cross the x-axis? Well, let's plot this real quick so we can see. And if we plot this, we're crossing the y-axis at 0, 0. So the 0 is 0. That doesn't mean there's no zeros. It means there's a point at 0, 0. If there are no zeros, you will write none. Okay, for the next one. So looking at this, A is a negative 1. B, the number in front of x is 4. And there's no third term, so C is 0. Which means my y-intercept, because that's my C, is 0. Since this A is negative, I have a maximum because it's going to be concave down. Before I find anything else out, let's plug these in. So I plug in 0. 0 times 0 is 0. Plus 4 times 0. 4 times 0 is 0. 0 plus 0 is 0. And I can either do these in my head or I can plug them into Desmos. So like for the next one, it's negative 1 squared plus 4 times negative 1. And I get negative 5. So it's up to you what you want to do. If you want to put these in or not, it's totally up to you. Do them in your head, do them not. Up to you. Oh, sorry, it's not negative 1. I was supposed to be plugging in 1. So it's not negative 5. Let's plug it in again. X was 1, so when we plug in 1, I get a 3. So 3 when I plug in 1. Apologize for that. So my first point is 0, 0. My next point is 1, 3. Let's try and get another one. Plug in 2. 2 squared is 4. Negate that, I get a negative 4. 4 times 2 is 8. Negative 4 plus 8 is 4. So 2, 4, 3. 3 squared is 9. Negate that, I get a negative 9. 4 times 3 is 12. Negative 9 plus 12 is a positive 3. And last but certainly not least, 4. 4 squared is 16. Negate that, you get negative 16. 4 times 4 is 16. Negative 16 plus 16 is 0. So you can put this in Desmos or do it in your head. And again, how I did that last one, we're doing the same thing, and it really helps when you put in Desmos because I can just change out 1 for 4, and I get 0 right here. Okay, so now that we have those points, let's find our axis of symmetry. So it's negative b, so negative 4 over 2 times a, negative 1. Negative 4, 2 times negative 1 is negative 2. Negative over negative is a positive. 4 divided by 2 is 2. So my axis of symmetry is at 2. And when x equals 2, y equals 4. So my vertex is at 2, 4. And if we go there, that is the turning point. So that is perfectly fine. Make sure you put arrows on your line. Okay. Next one. So my a here is 0.25. Since a is a fraction, is this getting wider or narrower? This should be getting wider. Also, a is positive. Is this concave up or down? It's concave up. And are we going to have a minimum or a maximum? We're going to have a minimum. Oh, we forgot our zeros over here. Sorry. Our zeros are when y equals 0, what's x? So when y equals 0, x is 0. And when y equals 0, x is 4. So my zeros are 0 and 4 for that last one. All right, my b here, there's no number right here, so we assume it's 1. So this is negative 1. And then 3 is my c. All right, my y-intercept is c. So this is at 3. So I can go to 0, 1, 2, 3 and plug that in. And that means when x is 0, y is 3. I already know that one, so I don't have to do any more with that. Now let's plug these other ones in. So I plug in negative 2. We're going to actually do this in Desmos. So keep this kind of with you, and we're going to do all of them together because going back and forth might be a lot. So we have 0.25 parentheses negative 2. Remember, whenever I do it in parentheses. Squared minus parentheses negative 2 plus 3. So I get 6. So you should have 6 there. Now the next one I'm plugging in is 2. So I don't have to rewrite the whole thing. Just take this thing out of the parentheses and put in 2 instead. And I get that y is 2. For the next one, I'm plugging in 4. So plug in 4. You have to plug into both parentheses. I get 3. And as you can see, I'm starting to make, like here it goes 0, 3, 4, 3, 0. I'm starting to make my pattern. Here 6, 3, 2, 3. So the next one should be 6. Let's double check. Plugging in 6. And I get 6. So now that we have these points, let's plot them. So I have negative 2, 6, 0, 3, 2, 2. 4, 3, and 6, 6. And as you can see, this graph is wider than our last ones. Now the axis of symmetry, let's go ahead and figure that out. So it's negative b, which is negative negative 1, so a positive 1, over 2 times 0.25. Okay, so this is going to be 1 over 2 times 0.25 is 0.5. 1 divided by 1/2 or 1 divided by 0.5 is 2. So my axis of symmetry is at 2. And when x is 2, y is 2, which means my vertex is at 2, 2. Which makes sense because that's right here. Now, what are the zeros? Where does this cross the x-axis? Well, this never crosses the x-axis. And you never get a 0 for y. So there are no zeros. We just write none. Okay, we're going to do 2 more. So for number 4, my a, there's no number in front of here, so it's a 1. B is 2, and C is negative 8. One thing we're going to learn about on next week, sometime next week, is going to be factoring. And with factoring, I can tell you right now that our zeros are going to be negative 4 and 2. just because I factored this in my head. Okay, so let's practice this. We're going to plug -4 in. I'm going to put this into Desmos, and we'll plug all of them in to make our lives easier. So we do -4 squared. Oh, let me erase all this first. -4 squared plus 2 times -4. Remember, always in parentheses, minus 8. Okay, so the first one is 0. So I should get a 0. The next one I'm going to plug in is -3. Guess I just need to get rid of the 4. And I get -5. The next one I'm going to plug in is -2. Just going along with the chart. And I get -8. The next one I'm plugging in is 0. And I get -8. And then the next one I'm plugging in is 2. And I get 0. Now, the reason that this isn't perfectly lining up like our last one is that we don't have the same difference between the x's. So that's why it's going to be a little bit different. Let's plot these. We have -4, 0, -3, -5, -2, -8, 0, -8, and 2, 0. Now let's find our axis of symmetry. It's -b, so -2 over 2 times 1. 2 times 1 is 2, so -2 divided by 2 is -1. So x equals -1, and we can see kind of a turning point there. Now we're going to need to plug -1 in to find our vertex. So I'm going to go back over here and plug in -1, which makes sense because if we go back to here, it's between the -8s, and -1 is between -2 and 0. It's halfway in between. So we're going to plug in -1, plug in -1, and I get -9. So my vertex is at -1, -9. This has a minimum because it's concave up because A is greater than 0, 1. Greater than 0, sorry, it's positive. The y-intercept is -8 because that's your C. And the zeros, the y equals 0 at -4 and at 2, just like I said, but we can also see that on the graph. Now, your work for today is to do the rest of these 5, and I'm going to zoom out so that, oh, sorry, we're going to do one more, and then you're going to do 4. We're going to do one more. Make sure, as we do this last one, I would highly suggest pausing it, because your work today is going to be to do the rest of these, and I want you to be prepared to do that. So try pausing it and try doing this yourself first. So we get 1, 4, 5. Here we're going to get 5, 2, 1, 2, 5, and all I did was plug those into Desmos for you. We go to -4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, -3, +2, -2, +1, -1, +2, 0, 5, and I'm going to draw it. Now, I can see my axis of symmetry right here at -2, but let's double check. So it's -4 over 2 times 1, which is -4 over 2, which is -2. So x equals -2, my axis of symmetry, which means my vertex is -2, 1. My minimum maximum, I have a minimum because A is greater than 0. It's concave up. My y-intercept's at 5 because that's my C. And my zeros, where do I cross the x-axis? I never do. We never have a y at 0. So none. Okay. Now you're going to do the rest of these. You can do it on a separate sheet of paper, or you can print out this paper and do it on here. It's up to you. But you are doing 6, 7, 8, 9, and you are going to send me a picture of your work. I know you are capable of doing this. I hope you have a great day.